So far we've learned that you can have one solution to a system. So one solution would be an ordered pair, but actually there's special cases. Sometimes there isn't a clear single answer to a system of equations. So I'm going to show you in two different ways how to solve this system, and we'll see that it's a special situation. So first, I'm going to solve by substitution. So I'm going to see that I have y equals 2x plus 1, so I can substitute 2x plus 1 in for y in equation 2. So then I'm going to get 2x plus 1 equal to 2x minus 5. If I subtract 2x on each side, I'm going to get 1 equal negative 5, which is not a true equation. So this means that there's no solution. So if you think about the graph of two lines that would not have a solution, you'd have two lines that never intersect. So I'm going to also show this by graphing. So if I graph the first line, I start at 1, and I go up to right 1, up to right 1. Or I go down to left 1, down to left 1. It's still going to be the same slope. So if I connect the lines right here and graph the second line starting at negative 5 and go up to right 1, when the slopes are the same, so you have the same slope and different y-intercepts, you're going to get no solution when you graph it. When you're solving and you get a false statement, it also is going to be no solution. So you could solve by elimination or substitution. The second one, for B, I think will be easier to solve using elimination. So I'm going to multiply the top by negative 2. So I'll get positive 4x minus 2y equals negative 6. So now I have to add these two equations. So adding the second equation and then the new equation on the bottom, I'm going to get 0x plus 0y equals 0. Well, this will just be 0 equals 0. This is a true statement, so this means it's going to be infinite solutions. So I don't want to say all real numbers because not every number works, but there's going to be an infinite number of places where these two lines intersect because it's going to be the same line. So to graph the lines, I'm going to solve each of them for y to put it in slope-intercept form, or solve for y in each one. So I get 3 plus 2 right 1 plus 2 right 1 down to left 1 down to left 1. I'm kind of sloppy right here. It's so small, the graph. So I connect it. The second one, I'm going to solve for y. And I'm going to have 2y equals 6 plus 4x, because I add 4x to each side. Divide each side by 2, and divide each term by 2. I'm going to get 3 plus 2x. So it ends up being the exact same line. So it's got the same slope, the same y-intercept. It's the same line. So the number of solutions are all on these lines that are overlapping. It's infinite. So it's not all real numbers because over here is not a solution, over here is not a solution, but there are an infinite number of solutions on this line. So just to recap, right away, if you have different slopes, you're going to have one solution. If you have the same slope and different y-intercepts, you're going to have no solutions. The lines will never intersect. If you have the same slope and the same y-intercept, there's infinitely many solutions. And to recap, when you're solving, not by graphing, if you get x equals a number and your variables do not cancel out, you're going to get one solution. If your variables cancel out and you get a number that's not equal to the other number, you get a false situation, that's no solution. If your variables cancel out and you get a true statement, That's infinitely many solutions. Okay, let's try a few applications of this. An artist is buying art supplies. She buys 4 sketch pads and 2 palettes and $16 for that supplies. The following week, she buys 2 sketch pads and 1 palette and pays $8. Write a system of linear equations that represents the situation. Can you find the price of 1 sketch pad? So again, I look at my last question to figure out my variables. So I'm going to have sketch pad be X and then palettes be Y. So I'm solving 4 sketch pads plus 2 palettes equals 16. And then I'm going to have 2 sketch pads plus 1 palette equals 8. So to solve the system, you can use elimination or substitution. I can tell if I multiply the bottom one by -2, I'll get -4x minus 2y equals -16. And so when I add the top and the bottom equation, everything cancels out. So I get 0 equals 0. That's a true statement, so it's going to be infinite solutions. So there's an infinite number of different prices of a sketch pad. What this means is that we can't just pick any x or any y. We have to pick an x or a y that satisfies this first situation, and it's also going to satisfy the second equation. So can you think of a number that when you plug in x in the second equation, because the second equation is easier to me, if you plug in x and you get a y. So I'll try, let's see, if I buy 4 sketch pads, so 2 times 4 plus 0, I'll get 0, because 2 times 4 plus 0 is 8, so that's a solution. What if you buy 2 sketch pads, so 2 times 2 plus what number is 8, that's going to be 4, so that's a solution. So there's more than one solution. Okay, then in a canoe race, Team A is traveling 6 miles per hour and 2 miles ahead of Team B. Team B is traveling 6 miles an hour. The teams continue traveling at their current rates for the remainder of the race. Write a system that represents a situation. Will Team B catch up to Team A? So I'm going to let Y be the number of miles that they traveled, and then X be the time, because we have distance and time. I know this because we're talking about miles per hour, which is a rate. So Y, Team A is traveling 6 miles an hour, but they're 2 miles ahead. And the second one is just traveling 6 miles an hour. So there's no way, I can see off the bat that there's no way that they're going to catch up, because they're both, one is starting 2 miles ahead, and they're both going at the same rate. So it'll never catch up. So no. You can also tell because it has the same slope, but different y-intercepts. Okay, I picked this last one to do because it's just a popular example of a ACT or SAT question. So what value of k will make the system have no solution? So if we have to remember that if it has no solution, it means you have different y-intercepts, but the same slope. So we want to figure out the slope. The slope is the number in front of x when you solve for y. So what I'm going to do is I'm going to solve for y in equation 1. And then I'm going to solve for y in equation 2. So if I solve for y in equation 1, I get negative ky equals 12 minus 3x. Then I divide by negative k. My whole point is trying to find the slope of each line. So the slope of this line is negative 3 divided by negative k. Okay, that's the coefficient of x. So I'm going to write this slope is 3 over k. Okay, it is okay to have a slope not be a number. It can also be an expression. So now I'm going to find the slope in the second line. So I'm going to solve for y in the second line. So I have 8y equals 20 minus 4x. Divide both sides by 8. I only care about the slope. And my slope is going to be negative 1/4. So I'm going to set these two expressions equal because I want the slopes to be the same because it has no solution. So I'm going to cross multiply and I get negative k equals 6. So k has to be negative 6.